wildfires soon reshape entire human civilization forever. Climate change is silently turning forests into ticking firestorms worldwide. Every year, devastating fires grow stronger, faster, and more unpredictable. Scientists warn that wildfire seasons are becoming dangerously longer. Each decade, communities near forests now live under constant evacuation, anxiety threats. Rising temperatures, dry vegetation creating perfect conditions for massive wildfires, wind patterns increasingly spread flames across vast regions within hours. Dry seasons now extend longer, leaving forests dangerously vulnerable. Worldwide, human activity accidentally ignites most of these catastrophic wildfire events. Lightning strikes also trigger massive fires in parched landscapes. Frequently, once small fires now escalate into uncontrollable infernos. Within minutes, firefighters struggle as resources become overwhelmed during extreme wildfire seasons. Smoke from wildfires travels thousands of miles, affecting global air quality. Wildlife habitats are destroyed rapidly, forcing animals into urban areas. Entire ecosystems collapse after repeated exposure to intense fire cycles. Scientists link rising carbon emissions directly to worsening wildfire behavior. Dry lightning storms have become more common in warming climates. Deforestation removes natural barriers that once slowed fire spread. Urban expansion pushes homes dangerously close to forest fire zones. Insurance costs rise sharply as wildfire risks increase annually. Emergency evacuation systems often struggle during rapid fire outbreaks. Dry winds like Santa Ana intensify. Fire spreads significantly. Satellite monitoring now tracks wildfire growth in real time globally. Fire seasons are no longer seasonal, but almost year-round. Heat waves contribute heavily to extreme wildfire. Ignition conditions worldwide, dry soil moisture levels make fire containment extremely difficult. Climate models predict even more severe wildfire events ahead. Fire-resistant infrastructure becomes essential in high-risk regions. Today, worldwide, rural communities often lack resources to fight large wildfires. Global warming accelerates vegetation dryness across multiple continents. Rapidly, fire breaks are becoming less effective under extreme climate conditions. Public health suffers from prolonged exposure to wildfire. Smoke evacuation routes can become blocked by fast-moving flames. Wildfire suppression technologies are evolving, but still severely limited. Dry forests act like fuel waiting for ignition sources. Wind-driven firestorms can leap across highways and rivers. Climate change increases frequency of extreme fire weather. Days, firefighters risk their lives battling unpredictable infernos every single day. Satellite data reveals rapid expansion of global fire zones. Climate scientists now call wildfires a growing planetary emergency. Communities must adapt quickly to survive escalating fire threats. Insurance companies are withdrawing coverage from high-risk zones. Climate change significantly reduces moisture retention in forest ecosystems. Long droughts create perfect ignition conditions for wildfire. Fire behavior becomes harder to predict under climate change. Urban-wildland interface zones face highest wildfire risks today. Dry lightning strikes ignite fires in remote wilderness areas. Global cooperation is essential to address wildfire climate crisis. Fire season maps show alarming expansion across multiple continents. Vegetation stress from extreme heat makes forests highly flammable. Wildfire smoke severely affects respiratory health across large populations. Climate-driven fire feedback loops worsen global warming effects. Fire suppression costs continue rising each passing year dramatically. Remote sensing technology helps detect wildfires before they spread. Climate change significantly intensifies heat waves that trigger wildfire outbreaks. Fire-resistant building codes significantly help reduce wildfire destruction risks. Improved forest management practices can significantly mitigate wildfire intensity. Stronger climate policies aim to reduce global fire risks. Wildfires release massive carbon emissions into the atmosphere rapidly. Advanced early warning systems save lives during fire emergencies. Climate change urgently demands global wildfire mitigation action. Now, fire seasons increasingly overlap across global hemispheres. Worldwide, wildfire disasters are becoming increasingly frequent and severely destructive. Human responsibility plays a major role in wildfire prevention. Understanding wildfire threats is crucial for protecting our future generations. Climate change is no longer future threat, but present wildfire reality. Rising global temperatures directly increase wildfire frequency across vulnerable regions. Heat waves dry forests faster than natural recovery can occur moisture. Loss in vegetation creates highly flammable forest conditions. Scientists observe wildfire seasons starting earlier and ending much later. Carbon pollution traps. Heat intensifying extreme fire weather events, drought conditions are becoming longer and more severe globally. Even normally wet regions now experience unexpected fire outbreaks, warmer winters fail to restore forest moisture levels adequately, snowpacks are melting earlier, reducing summer water availability, reduced rainfall leaves, landscapes dangerously dry for extended periods. Climate models show wildfire risk increasing across all continents. Fire-prone areas are expanding into previously safe ecosystems. Rising temperatures weaken natural fire resistance in forests. Dead vegetation accumulates faster, creating larger fuel loads. Climate change alters wind patterns that spread fires rapidly. Stronger winds carry flames across previously safe distances. Easily, lightning frequency increases in hotter, unstable atmospheric conditions. Dry thunderstorms ignite fires without significant rainfall protection. Human-caused warming increases ignition probability in many regions. Forest ecosystems lose balance under prolonged heat stress conditions. Trees become weaker and more susceptible to fire damage. Pest outbreaks worsen forest health, making fires more destructive. Bark beetles kill vast forests, creating dry fuel zones. Climate change disrupts natural regeneration after wildfire events. Soil becomes drier, reducing regrowth. Potential after fires. Wildfires now burn hotter than recorded in previous decades. Extreme fire intensity destroys even fire-adapted ecosystems. Quickly, fire suppression becomes harder under rapidly changing climate conditions. Heat trapped in urban areas increases nearby wildfire risks. Atmospheric instability leads to unpredictable firestorm behavior patterns. Fire whirls and tornado-like flames appear in extreme conditions. Scientists link Arctic warming to global wildfire pattern changes. Permafrost thaw contributes indirectly to vegetation drying processes. Ocean temperature shifts influence global fire weather systems. Climate change amplifies El Niño effects on wildfire seasons. Vegetation cycles no longer match historical climate patterns. Rainfall unpredictability leaves forests vulnerable to sudden ignition. Extreme drought zones now appear in unexpected geographic regions. Wildfire smoke feedback loops intensify atmospheric warming effects. Burning forests release stored carbon, accelerating climate change further. This creates a dangerous cycle of fire and warming. Fire seasons now overlap across hemispheres, creating global crises. Fire suppression resources are increasingly stretched beyond capacity. Emergency response times struggle against rapidly spreading flames. Satellite data shows exponential growth in fire-affected regions. Scientists warn of potential mega-fires in coming decades. These mega-fires may be too large to control climate-driven fire behavior, is becoming less predictable each year. Firefighters now train for extreme climate, intensified fire scenarios. Traditional fire management methods are becoming less effective. Forest management must adapt to rapidly changing climate realities. Controlled burns are used more frequently to reduce fuel buildup. However, climate change sometimes overwhelms even preventive strategies. Global cooperation is needed to reduce wildfire. Climate impacts, reducing emissions, can slow wildfire intensity growth over time. Renewable energy adoption helps limit future fire risk escalation. Climate adaptation strategies are becoming urgent for all nations. Communities must prepare for increasing wildfire exposure risks. Early warning systems are essential in climate-altered fire zones. Education about wildfire risks helps improve community resilience. Climate change is fundamentally reshaping how fires behave globally. The connection between heat and fire is now undeniable. Without action, wildfire devastation will continue escalating worldwide. Understanding this link is key to protecting our future. Wildfires are no longer remote disasters, but direct human threats. Expanding cities push deeper into natural wildfire-prone landscapes. This dangerous overlap is called the wildland-urban interface. Millions of homes now sit directly beside forest edges globally. As populations grow, fire exposure risk increases significantly each year. Construction in dry regions increases vulnerability to spreading flames. Roads and infrastructure often become fire pathways across landscapes. Human settlements can unintentionally fuel faster wildfire expansion. Abandoned agricultural lands become dry fuel sources over time. Poor land management increases accumulation of combustible vegetation. In some regions, fire suppression policies backfire over decades. Preventing small natural fires leads to dangerous fuel buildup. When fires eventually start, they become far more intense. Urban development fragments ecosystems, reducing natural fire control barriers. Power lines and equipment frequently spark major wildfire incidents. Human negligence remains a leading cause of ignition events. Campfires left unattended can escalate into massive disasters quickly. Climate change worsens these human-caused fires dramatically. Dry winds carry sparks from human activity across long distances. Expanding road networks increase access to remote fire-prone areas. Tourism in forest regions increases accidental fire risks. Construction heat and machinery sometimes ignite dry vegetation. Urban expansion reduces natural fire buffers like wetlands. Housing materials often lack resistance to extreme fire conditions. Fire evacuation becomes harder as populations in risk zones grow. Emergency services face overwhelming demand during urban wildfire crises. Communication systems can fail during large-scale fire emergencies. Smoke inhalation becomes a major health hazard in cities nearby. Hospitals often struggle with wildfire-related respiratory emergencies. Children and elderly are most vulnerable to smoke exposure. Insurance companies are retreating from high-risk fire regions. Economic losses from wildfires are increasing exponentially yearly. Entire towns have been destroyed within hours of ignition. Rebuilding after wildfires can take years or even decades. Some communities never fully recover after repeated fire events. Psychological trauma affects survivors long after fires end. Fire evacuation displaces thousands of families at once. Temporary shelters often become overcrowded during fire crises. Wildlife displacement increases human-animal conflict in urban zones. Climate change intensifies this human-wildlife-fire interaction cycle. Governments struggle to update outdated fire management systems. Urban planning often fails to consider long-term fire risks. Fire-resistant zoning laws are not always enforced properly. Rapid development often ignores environmental fire safety warnings. Infrastructure resilience becomes critical in fire-prone regions. Fire-resistant materials can significantly reduce property damage. Community awareness programs help reduce accidental fire starts. Technology like drones now assist in fire monitoring efforts. Early detection systems improve emergency response times significantly. However, extreme fires can still overwhelm modern systems. Climate change increases unpredictability of fire movement patterns. Wind shifts can turn safe zones into danger zones rapidly. Firebreak failures often lead to sudden, uncontrolled spread. Human settlements can become trapped by fast-moving fire fronts. Evacuation planning is now a critical survival necessity. Many regions are redesigning cities for fire resilience. Nature-based solutions help reduce surrounding fire risks. Restoring wetlands and forests can slow fire expansion. Human adaptation is essential in the face of climate-driven fires. Communities must learn to live with increasing fire reality. Awareness of risk zones saves countless lives annually. Collaboration between scientists and planners improves safety outcomes. Human expansion has amplified wildfire consequences worldwide. Without planning, future fire disasters will become even worse. Understanding human impact is key to reducing wildfire destruction. Wildfires follow complex scientific patterns driven by heat fuel and wind. Fire behavior depends on temperature, moisture, and vegetation density levels. Scientists study how flames transfer heat through radiation convection and conduction. Radiation preheats nearby fuels, making ignition faster in dry conditions. Convection carries hot air upward, spreading fire vertically and horizontally. Strong winds push flames rapidly across large landscapes within minutes. Fuel type determines how fast and intensely a fire burns. Dry grasses ignite quickly but burn out faster than forests. Dense forests can sustain long-lasting, high-intensity wildfire events. Moisture content in plants is key factor controlling fire spread. Lower humidity increases probability of rapid fire ignition significantly. Fire intensity increases exponentially with rising temperature and dryness levels. Scientists use computer models to predict wildfire movement patterns. These models simulate wind speed, terrain, and fuel availability factors. However, real wildfires often behave unpredictably despite advanced modeling tools. Topography plays a major role in directing wildfire speed and direction. Fires move faster uphill due to heat rising along slopes. Valleys can trap heat, creating dangerous fire acceleration zones. Rocky terrains sometimes slow fires, but not always effectively. Vegetation oils and resins act as natural accelerants in forests. Pine forests are especially vulnerable due to high resin content. Dead trees create continuous fuel pathways for spreading flames. Firebrands or burning debris can travel miles ahead of fire. These firebrands start new fires far from original ignition points. This process is called spotting and increases fire unpredictability. Extreme heat creates firestorms that generate their own wind systems. These self-feeding fires become nearly impossible to control. Pyrocumulus clouds form when intense fires heat the atmosphere. These clouds can produce lightning that starts additional fires. Fire energy releases massive amounts of heat into surrounding air. This heat dries nearby vegetation, accelerating fire spread further. Scientists classify fires based on surface, crown, and ground levels. Crown fires move through treetops and spread extremely fast. Ground fires burn underground roots and organic soil layers. Surface fires consume leaves, grass, and smaller vegetation layers. Mixed fires combine all types, making suppression very difficult. Fire suppression techniques depend on understanding fire classification. Water drops from aircraft cool and slow fire edges. Fire retardant chemicals reduce flammability of vegetation temporarily. Bulldozers create fire breaks by removing fuel in fire paths. Backburning intentionally removes fuel ahead of advancing wildfire fronts. However, extreme weather can make these strategies ineffective. Climate change increases frequency of high-intensity fire conditions. Hot, dry air reduces effectiveness of natural fire barriers. Scientists track fire energy using satellite thermal imaging systems. These images reveal hidden hotspots within burning landscapes. Wind direction changes can suddenly shift entire fire behavior. Fire spread rate can double within minutes under strong winds. Lightning-induced fires often occur in remote, inaccessible areas. These remote fires grow unnoticed before becoming large disasters. Fire science continues evolving to improve prediction accuracy. Machine learning now helps analyze wildfire risk patterns globally. Researchers combine climate data with fire history records. This improves forecasting of future wildfire-prone regions. Despite advances, fires still remain partially unpredictable natural forces. Understanding fire science is key to better prevention strategies. Improved models help governments plan evacuation and response systems. Fire research supports development of safer building codes. Education about fire behavior increases community preparedness levels. Firefighters rely heavily on science-based operational decisions. Continuous research is essential as climate conditions rapidly change. Wildfire science bridges gap between nature and human safety. Every wildfire teaches scientists new lessons about fire behavior. Learning from fires helps reduce future disaster impacts. Science remains our strongest tool against growing wildfire threats. Wildfires leave devastating scars across landscapes, affecting ecosystems for decades. Entire forests can take generations to fully recover naturally. Soil quality dramatically decreases after repeated intense wildfire exposure. Nutrient loss in burned soil slows vegetation regrowth significantly. Wildlife populations are displaced or completely destroyed during fires. Many species lose critical habitats needed for survival immediately. Some animals struggle to adapt to rapidly changing environments. Food chains are disrupted, causing long-term ecological imbalance. Rivers and water sources become polluted by ash and debris. This contamination affects drinking water supplies for nearby communities. Air pollution from wildfire smoke reaches dangerous health levels. Fine particulate matter penetrates deep into human lungs easily. Respiratory diseases increase significantly during wildfire seasons worldwide. Hospitals experience sudden surges of patients with breathing issues. Long-term exposure increases risk of chronic lung diseases. Children are especially vulnerable to wildfire smoke exposure effects. Elderly populations face higher mortality risks during severe fire events. Wildfire smoke can travel across continents, affecting distant populations. Climate change worsens these health impacts year after year. Carbon emissions from fires contribute further to global warming. This creates a dangerous cycle of fire and climate damage. Economic losses from wildfires reach billions of dollars annually. Homes and businesses are destroyed within hours of fire spread. Infrastructure damage includes roads, power lines, and communication systems. Agricultural lands are burned, reducing food production significantly. Farmers lose crops, livestock, and livelihoods during wildfire disasters. Tourism industries collapse in fire-affected regions temporarily. Insurance premiums rise sharply in wildfire-prone areas globally. Some regions become uninsurable due to extreme fire risk. Governments spend enormous budgets on fire recovery and response. Rebuilding communities after fires takes years of effort. Emotional trauma impacts survivors long after physical damage ends. People lose sentimental belongings that cannot be replaced. Displacement causes long-term social and psychological stress. Community networks are disrupted when entire neighborhoods burn. Schools may close temporarily, affecting children's education. Firefighters face physical and mental exhaustion during long fire seasons. Emergency resources are stretched thin during multiple simultaneous fires. Rural economies suffer more due to limited recovery support. Wildfires increase inequality between wealthy and vulnerable communities. Insurance gaps leave many families without financial recovery options. Rebuilding costs often exceed available government assistance programs. Climate change intensifies these economic burdens every passing year. Forest industries suffer from reduced timber availability after fires. Water treatment costs rise due to contaminated sources. Air quality alerts lead to reduced outdoor economic activity. Worker productivity declines during heavy smoke exposure periods. Transportation systems are disrupted by fire and smoke conditions. Airports and highways often close during major fire events. Supply chains are affected in fire-impacted regions. Businesses face long interruptions during evacuation periods. Local governments struggle with emergency management funding shortages. Reforestation efforts require significant time and financial investment. Ecosystem restoration projects depend on long-term planning. Scientific monitoring is needed to track recovery progress. Some landscapes may never fully return to original state. Biodiversity loss becomes permanent in severe fire regions. Climate feedback loops worsen environmental damage after fires. Public health systems must adapt to recurring smoke events. International aid is sometimes required for large wildfire disasters. Insurance markets are reshaping due to increasing wildfire risks. Economic resilience depends on improved climate adaptation strategies. Wildfires highlight deep connection between environment and economy. Human systems are increasingly vulnerable to fire disasters. Understanding consequences is essential for building a safer future. The future of wildfires depends on how quickly humanity acts today. Reducing greenhouse gas emissions is the most critical long-term solution. Slowing climate change directly reduces wildfire intensity and frequency. Transitioning to renewable energy helps stabilize global temperatures. Gradually, sustainable forest management reduces excess fuel buildup in ecosystems controlled or prescribed. Burn safely, remove dry vegetation in advance. These planned burns prevent larger, uncontrolled wildfires. Later, improved land management reduces risk in high fire zones. Significantly fire-resistant building materials protect homes in vulnerable regions. Creating defensible space around homes slows fire spread effectively. Early warning systems save lives by detecting fires quickly. Satellite monitoring allows real-time tracking of wildfire growth. Drones are increasingly used for fire surveillance and mapping. Artificial intelligence improves prediction of fire behavior patterns. Better weather forecasting helps anticipate fire-prone conditions. Community education increases awareness of fire prevention methods. Evacuation drills prepare residents for emergency situations safely. Stronger urban planning reduces expansion into high-risk fire zones. Fire breaks strategically slow or stop advancing flames. Restoring wetlands and forests increases natural fire resistance. Reforestation helps rebuild ecosystems after wildfire damage. Planting fire-resistant tree species reduces long-term risks. Indigenous land management practices offer valuable fire control knowledge. Global cooperation is essential for addressing climate-driven fires. International funding supports fire recovery in vulnerable regions. Governments are improving emergency response coordination systems. Firefighter training is evolving to handle extreme fire behavior. New protective gear improves safety during high-intensity fires. Aerial firefighting technology continues to advance rapidly. Water-bombing aircraft help contain large fire outbreaks. Fire retardant chemicals are being improved for environmental safety. Climate policies aim to reduce long-term wildfire risks globally. Urban design is shifting toward fire-resilient community planning. Smart sensors detect heat and smoke in early fire stages. Public alert systems notify citizens instantly during emergencies. Community shelters are being improved for rapid evacuation. Safety insurance systems are adapting to increasing wildfire risks. Research institutions are developing advanced fire simulation models. International wildfire databases improve global understanding of fire patterns. Public-private partnerships support wildfire prevention efforts. Education campaigns teach safe outdoor fire practices. Responsible tourism reduces human-caused ignition risks. Energy grid modernization prevents electrical fire outbreaks. Underground power lines are being considered in high-risk areas. Forest thinning projects reduce fuel density in critical zones. Restoration of natural fire cycles helps ecosystem balance. Climate adaptation planning is now essential for all countries. Local communities play key roles in fire prevention success. Volunteer firefighting networks support professional emergency teams. Resilient infrastructure reduces long-term disaster recovery costs. Data sharing between countries improves wildfire response strategies. Investment in green technology reduces environmental fire risks. Public awareness about climate change strengthens prevention efforts. Long-term research is crucial for understanding evolving fire behavior. Innovation in robotics may assist future firefighting operations. Fire prediction systems will become more accurate over time. Community resilience depends on preparedness and adaptation. Nature-based solutions are key to sustainable fire management. Human responsibility remains central in preventing future disasters. Climate action today shapes wildfire risks for future generations. With global effort, wildfire destruction can be significantly reduced. Adaptation ensures societies can live safely in changing climates. Hope lies in combining science, policy, and community action. The future is still changeable through collective responsibility. Understanding and action together can protect our planet from fire threats.